Thank you all for being here today. My name is Caitlin Fournier, and I'm a math coach in the elementary and middle school. I've been at ASD for 4 years now and feel so fortunate to see what our little mathematicians in the elementary school are capable of. During our time together today, I'll share with you what math teaching and learning looks like for your children, with the hopes that you will feel better prepared to support their learning at home. We'll start with a video to ground our thinking today.
All right, so at the Math Forum, we worry a lot about problem solving and kids thinking about math and kids thinking that they can do math. And I'm going to talk a little bit about ways in which we do that, right? So long ago, sometime in the mid-90s, I was on an airplane and I was flying to Detroit. And I was going to do a sketchpad workshop, okay? So I gave up my window seat to a 3-year-old. And so his dad sat in the middle. It was late at night. The picture should be at night, but I couldn't find one. And the kid's looking out the window, and he's going, "Dad, what's that?" And Dad, being a good dad, is answering him. So, "Oh, it's this, it's this." And this goes on for a while. "What's that?" What's the dad answers. That's great. At some point, Dad apparently wasn't paying attention. And so he says, "What's that, Dad?" And I turned and I said to the kid, "Well, what do you think it is?" And he came, I don't remember what it was, but I know it was profound. And so the rest of the flight went on like that. He's saying, "Oh, what's that?" And we say, "What do you think it is?" And eventually he doesn't ask anymore. He just starts talking about what he's seen out the window, right? And so later on, we're walking through baggage claim, and I went ahead, and they caught up with me, and the guy says to me, "I listened to the way that you talked to my kid, and you really made him think." I'm going to talk to my son differently from now on. Thank you, all right?
I listened to the way you talked to my kid, and you really made him think. Think back to when you were in elementary school. What are your memories of math? What did thinking look like? Let's continue this journey into the past. Over the next few minutes, I will invite you to complete a few problems. I will not ask you to share your solutions or your strategy. Feel free to take a moment now to get some paper and something to write with if you'd like. Take some time to solve this problem in whatever way makes sense for you. If you learned math like I did, you most likely set up the problem like this, with the bigger number on top, because that's what we were told to do. Does it really matter which number goes on top? Then you might have gone step by step. 9 and 8 is 17. I put down the 7 and carry the 1. 9 and 9 is 18, plus 1 more is 19. I put down the 9 and carry the 1. 1 and 1 is 2. 199 plus 98 equals 297. Go ahead and take some time to solve this problem in whatever way makes sense for you. If you learned math like I did, you most likely set up the problem like this and used what we call the standard algorithm. I'm going to walk through this problem and articulate what my 4th grade self would have said. I look all the way to the right, and I can't take 7 from 1. So I move to the left, but I can't take 9 from 0. So I borrow from the 4 and make that a 3. I give the 1 to the 0 to make it a 10. I still can't take 7 from 1, so I need to borrow again. I borrow from the 10 to make it a 9. And I give that 1 to the 1 to make it 11. 11 minus 7 is 4. 9 minus 9 is 0. 3 minus 1 is 2. Therefore, 401 minus 197 equals 204. Take some time to solve this problem in whatever way makes sense for you. What is 15 times 12? If you learned math like I did, you most likely set up the problem like this and used what we call the standard algorithm. My 5th grade self would have said things like, "I crossed out the 2 because I'm done with it." And with saying that, I automatically would have added a 0 underneath the 30. If you learned math like I did, you probably would have done a lot of things without knowing why. Oftentimes, math of the past was taught as a recipe where there is a series of steps to follow. As long as you could follow the steps in the recipe, you were considered successful. Here you'll see Keith Devlin's quote reading, "When today's parents were going through schools, the main focus on mathematics was on mastery of a collection of standard procedures for solving well-defined problems that have unique right answers. If you did well at that, you're pretty well guaranteed a good job. Let's move into what math teaching and learning is all about today. For many parents, math teaching and learning of the present feels a bit like this.
Common Core is taught in a way that most people over 20 don't recognize.
We find ourselves tearing out our hair at the new math.
It's the same thing I do when I get a check at a restaurant, draw a bunch of shapes and tell the waitress to find my error.
The way in which students learn math is no longer like following a recipe in a cookbook. The math cookbooks of the past have become obsolete as we now have tools at our fingertips to compute for us. The emphasis has gone from what we do as mathematicians to how and why we do what we do. We had looked at this problem earlier today. A student in today's classroom might look at the problem and reason through the problem by using friendlier numbers. In this case, a student rounds the addends and adjusts the sum accordingly. Or a student might use another strategy involving compensation, where he or she takes from one addend and gives it to another. Let's compare the two strategies. How many of us knew what we were doing when we carried the 1 using the traditional algorithm on the left? Did you realize that 9 ones and 8 ones are 17 ones? And when we carried the 1, we were actually redistributing a group of 10? I didn't realize this until I was an adult. Which strategy shows the what? And which strategy shows the how and the why? Which strategy is more efficient? As we think through these questions, I encourage us to think back to that airplane video at the start of our session today. We're always having thinking at the heart of what we do. We also looked at this problem. A student in today's classroom might look at the problem and reason through the problem by using friendlier numbers. In this case, a student takes away 200 instead of 197 and adjusts the difference accordingly. Or a student might use what they know about the relationship between addition and subtraction to count up from 197 to 401. Let's compare the two strategies. How many of us knew that when we said we couldn't take 7 from 1 using the algorithm on the left, that we actually could? Didn't we learn in middle school that 1 minus 7 is -6? Which strategy shows the what? And which strategy shows the how and the why? Which strategy is more efficient? Which strategy involves thinking? Now let's go back to this problem. What is 15 times 12? A student in today's classroom might look at the problem and reason through it by breaking apart one of the factors. In this example, 12 is broken apart into 10 and 2. And rather than seeing the problem as 15 groups of 12, one can think of it as 15 groups of 10 and 15 groups of 2. Another student might break apart the 15 instead of the 12. Rather than seeing the problem as 15 groups of 12, one can think of it as 10 groups of 12 and 5 groups of 12. Another student might choose to break apart the 12 into 6 and 6. In all of these cases, students are using helper facts to support them. They're using what they know to make problems easier. Or in this case, a student might create an equivalent expression by doubling one factor and halving the other. Does it always work? And why does it work? Interesting questions that I certainly did not explore as a child. Let's compare the two strategies. How many of us knew that when we were using the algorithm on the left, that we were actually breaking the 12 apart into 10 and 2 and multiplying 15 by each? I didn't make the connection until I started teaching math. Which strategy shows following a procedure and which strategy shows reasoning? Which strategy is more efficient? And which strategy really involves deep thinking? The strategies that you see here are all examples of fluency, which means accuracy, flexibility, and efficiency with math facts. Fluency is just one facet of math education today. Equally as important are conceptual understanding and application. Students today engage in mathematics that allows them to develop fluency and conceptual understanding and apply their understanding to novel situations so they're prepared prepared for problem solving in the future. Ultimately, we want our students to be flexible thinkers with a variety of strategies at hand so that when we throw them into the kitchen, they can whip up a meal without consulting a cookbook. Let's explore what this might look like in a classroom. Mathematics of the past often looked like this. Really, it's just arithmetic. We might add some context in the hopes of making it more meaningful or engaging to students, but let's be honest, most students don't really care how many pretzels Jim or Susie have. We could also provide a context without numbers. Here, students would need to consider things like a reasonable number of pretzels for each person, how many people would be attending the picnic, etc. Which task involves most thinking? Which task best prepares students for messy problem solving in the future? Take a minute now to think about some similar questions you might pose at home. 3-act tasks are often used in the classroom to encourage students to ask questions, and seek out information to answer those questions. We're going to walk through one together now. As you watch the following video, please make note of what you notice and what you wonder. After watching that video together, students would share what they noticed and what they wondered. It's always so remarkable listening to their wonderings. The range is just so interesting. As a class, we'd choose one question to focus on. In this case, our question might be, how many Skittles fit in the light bulb? Once a class identifies a question to pursue, students would then identify what information they need to solve the problem. That begins Act 2. In Act 2, there would be a reveal of the information that students had requested. In this case, Act 2 consists of the amount of Skittles in the light bulb. Once Act 2 key information is revealed, students use that information to solve the problem. Finally, in Act 3, the solution is revealed. In grade 2, students are expected to add up to 4 two-digit add-ins. Students could simply be given a task like the one you see on the left, where they're given 4 add-ins and they just add them up. Or they could engage in a 3-act task in which multi-add-in addition is part of the problem-solving process. Again, going back to our airplane, which task involves more thinking? Well, you won't necessarily be creating 3-act tasks this summer. Take some time now to think about what life will be like for you this summer and what mathematical questions your child might explore in that given context. In grade 5, students learn about volume. This is the type of work I did as a child when I learned about volume. Now consider how the image on the right might invite students to inquire about volume. Which one comes in a messy, real-world context, preparing students for future success? Which one involves more thinking? Once again, take some time to think about what your family's life will be like this summer and think about how problem solving might fit in. Which one doesn't belong is an instructional strategy that is used in the classroom to support students' conceptual understanding and their ability to construct an argument. This routine asks students to look at 4 items and try to find a reason why each one does not belong with the others. Essentially, students have to compare and contrast the 4 items using a mathematical lens. We'll walk through one together. Take some time to look at these items and create an argument for why each one does not belong with the others. A student might say A doesn't belong because it's the only 3-dimensional shape. Another student might say D doesn't belong because it's a pentagon, and the others are either quadrilaterals or have faces that are quadrilaterals. In grade 2, students are expected to identify shapes and describe and compare their attributes. As you think about what that expectation is, which task involves more thinking? Take some time now to think about how you might encourage your child to compare and contrast different things and construct mathematical arguments at home. Like which one doesn't belong, and would you rather, students have to make some mathematical comparisons. Take some time to consider the options and think about how you might go about making a choice. Now compare that task to the one on the right. In grade 3, students are expected to compare fractions. Which task requires students to think more deeply? If you look around you, you'll see some potential for similar would you rather tasks all around. I encourage you to create some that are interesting and age appropriate for your child. As we wrap up today, let's go back to where we started.
Later on, we're walking through baggage claim, and I went ahead and they caught up with me, and the guy says to me, I listened to the way that you talked to my kid, and you really made him think. It was right. I'm going to talk to my son differently from now on. Thank you. All right.
Children don't need worksheets upon worksheets or the next grade level content to experience rigor in mathematics. They just need opportunities to solve problems. This summer, I challenge you to look around and explore those problems with your child. Let's talk about some resources that might support you in doing so. Here are some resources that will support your own learning. Keep in mind that there's no one perfect resource. Some of them may have bits and pieces that speak to you. I will also share this list via Google Doc in just a minute. As you think about what tasks you might engage in with your child this summer, here are some suggestions. Again, remember that there is no perfect task. The goal is to engage your child in thinking mathematically. I'm going to populate the chat right now so that you all have the link to these resources. And as we wrap up today, we'll now have some time for questions if you have some. I've also included my email here so that you can reach out to me directly if you have some questions based on our learning today. If you have questions, please populate the Q&A now. We'll take another minute for questions. So once again, those resources have been shared with you through the chat function of our call. Please do again reach out if you do have some questions as you let all of this information simmer. Thank you for joining today and enjoy the rest of your day.